wonderful to be here, and thanks, Camilla, for that amazing overview. Let me just say that when Henry called me that day, and we spent those 2 days brainstorming, he came up with this idea of, let's set up a jury of 100 scientists. And I said, you're crazy. It's impossible. You can't get 100 academics to agree on an outcome for a prestigious academic prize like this. And we did 100 invites, and everyone responded positively. So we have the dream jury. I could really list up the dream scientists, and all accepted, and we've done this twice now, and it's challenging, but it's a real joy. So it was a brilliant idea to set up this very, very challenging but very ambitious, the most ambitious science prize for integrated social and natural sciences research on planetary boundaries. What I want to do now is to give you a bit of the journey, the scientific journey behind the planetary boundary science, but also an update of where we are in terms of why we can today say, I would argue unequivocally, without any hesitation, that we are putting the stability, the resilience, and the life support on planet Earth at risk. We've come to that juncture. We're hitting the ceiling of what we scientifically call hardwired biophysical processes that regulates the very stability of the planet. We're pushing the planet right at the edge of what it can cope with in terms of anthropogenic pressures. This is 15 years of scientific advancements, but it's also building on so much evidence over 30 years of massive advancements in Earth system science, resilience theory, paleoclimatic research, and all the systems ecological research. And of course, I would argue that perhaps one of the most important starting points for the planetary boundary science is the conclusion, which came, I would argue, and I know the Sybil Seinsinger is in the room here, who headed the International Geosphere Biosphere Program, which in 2007 put out the most important volume, I would argue, summarizing 30 years of science, concluding the great acceleration, that we up until the 1950s have this linear impact on the planet. We are a relatively small world on a big planet, but then we take off in this exponential rise. You've seen the hockey sticks. We tend to talk only about carbon dioxide, but I can tell you, you can pick any parameter that matters for the economy, for our human well-being, for sustainable development goals, for planetary stability. It looks the same. You come to the mid-1950s, and then it's the takeoff point. And we rise in the great acceleration, well established today, which led Nobel laureate Paul Crutzen, one of the co-authors, by the way, of the first planetary boundary papers in 2009, to conclude we're no longer in the Holocene. We're pushing ourselves into a whole new geological epoch. Greek for humans, anthros. Anthros are now the dominating force of change on planet Earth. Welcome to the Anthropocene. And just as Camilla pointed out about the scale of speed of advancements in science, well, unfortunately, we have the same challenge with regard to the speed and scale of human negative pressures on the Earth system. That is the basis for the planetary boundary science. And we asked 2 questions in the theory on the planetary boundary science, based on all these pressures, based on the risk of tipping points, based on the fact that we are risking to drift away from the Holocene. 2 questions arise. Number one, and this is like the whole theory of planetary boundary science. Number one is, what are the biophysical Earth system processes and systems that scientifically are proven to regulate the state of the planet, the functioning of the planet, and the ability of the planet to buffer and provide life support? Once those systems are identified, and I can tell you we turned every stone and we invited all disciplines. We had massive workshops, 2004, 2005, 2006, 2007, and we found 9 candidates. Then comes question number 2. For these 9, can we identify control variables that regulates these Earth system processes, the boundary processes, and can we quantify, based on the best scientific evidence we have, based on the uncertainty range, which definitely is there, a boundary point beyond which we risk causing feedback dynamics and interaction that can make us drift away from losing more and more life support, but within which we have a high likelihood of remaining as close as possible to the planet that has enabled civilizational journey as we know it, that planet we depend on, the Holocene planet, the Holocene being the reference point. That gave us the boundary, the safe boundary, and when you add all these together, it gives us the safe operating space for humanity. So there you have it. That's the planetary boundary framework theory, which has now gone through 3 iterations, and the most recent one published last year in 2023, and informing both the social and natural sciences today. And this is the basis, what you see on the screen here. Now, what I want to do just before coming to what this implies in the broader sense of governance and transformation, just to say that we are seeing already today, when 6 of 9 planetary boundaries are transgressed, that it's starting to hurt. You may know that on average over the past 15, 20 years, the cost for our unsustainable pressures on the Earth system is in the order of $100 billion per year. 2023 is very likely somewhere closer to $300 billion because of droughts, floods, heat waves, fires, reinforced storms in a human-amplified super El Niño event. So we have this cascade of evidence increasingly attributed to human environmental change. We all know that one driver of this is global mean surface temperature rise. You have seen the curves. What makes us really nervous from a planetary boundary perspective is not only that we are, for the first time, touching 1.5 degrees Celsius, which we reached in 2023. The IPCC average is 1.2 degrees Celsius, which is the average temperature over a 20-year period. What makes us really nervous is the following. You can barely see it on this curve, but from 1970 until 2010, the average increase caused by our climate forcing because of emission of greenhouse gases increased by 0.18 degrees Celsius per decade. 0.18 per decade, almost 0.2 per decade. But suddenly from 2010 onwards, we suddenly see a rate change. We jump up to 0.26 degrees Celsius per decade. So we're in an acceleration phase, and we do not understand why. But one thing is for certain, the most likely candidate is an Earth system losing resilience. An Earth system which is getting weaker and less able to buffer the stress caused by the massive energy imbalance that we have caused. One really, really nervous candidate for this, which has shocked the scientific community, many of you are experts in this room on this, is what we observed last year for ocean surface temperature. And this graph has been, in the scientific community, attributed as just a complete shock. Here you have the 1980 until today in gray lines, the gradual warming of the ocean. We understand this. Climate model shows it very clearly. 90% of the heat from our fossil fuel burning is absorbed in the ocean. The ocean is the massive Earth thermostat. This is the biggest buffering of the stress caused by our fossil fuel burning. The ocean gets warmer, a deep concern. Terry Hughes is in the room here, the world's leading coral reef scientist, showing the 4 consecutive coral reef bleaching events which are causing tipping points in the massive, massive marine ecosystems. But it is, after all, scientifically understood. Until suddenly, look at that orange line, in 2023 we just jump off the charts. A 0.3 degrees Celsius sudden abrupt jump in surface temperature. And then as if that was not enough, look at 2024, the black line, it just continues. We're somehow suddenly deviating away from anything that we've been able to predict and understand before. Actually, there's no climate models that can reproduce this. If anything, what you see on the chart here is what climate models in the CMIP6 of the IPCC can reproduce for a 3 degrees Celsius planet, not a 1.2 degrees Celsius planet where we are today. What is happening? We do not understand it. Is there a reason for concern? Yes. What can be a candidate? An Earth system losing resilience. So we're starting to see nervousness and signs of changes we had not expected. But we're also seeing more and more economic analysis showing more and more evidence that this is really starting to become uncomfortably large impacts on the global economy. You may have seen this work. I should be very transparent to say it actually comes from colleagues at the Potsdam Institute, Maximilian Koch et al., doing the most advanced econometric climate economics analysis so far, integrating for the first time both heat impacts and precipitation impacts, coming with the following conclusion. Already today, we are committed to a 19% reduction in GDP per annum by 2050 compared to business as usual trajectory, equivalent to $38 trillion of loss of income. So we're starting to talk double-digit impacts if we do not transform ourselves away from the journey we're on today. Now, I just want to take you also deeper into this, why this has so much to do with the need for us to reconnect to planet Earth. And it is because we can today talk of what I call the corridor of life. So what I've talked about so far is we're putting all this pressure and it's starting to cost. But what is it that we are putting on the line? What are we risking to lose? Well, we have so much paleoclimatic evidence today that I would argue that this slide alone would be enough for the world to rise and start transforming back into the safe operating space. And the story goes as follows. You see 400,000 years on the x-axis. It's ice core data. It's the latest Burke et al. Analysis. It's well established. And what you have here is, which actually dates back all the way to 1 million years, the Milankovitch cycling between 100,000 years of ice age, these periods here, and the short 15 to 30,000 years of warm interglacials. We have 6 to 8 of these. This is 1 million years, and it's very narrow. As we understand it scientifically today, we never, during this entire period, passed 2 degrees Celsius. The warmest global mean surface temperature on Earth, compared to the pre-industrial 14 degrees Celsius, never exceeded beyond 2, and deep ice age is roughly minus 5. I call this the corridor of life. Why is that so? Well, because we have only been modern humans on planet Earth from this point onwards. We've only lived on planet Earth as modern Homo sapiens through 2 ice ages and 2 interglacials. Actually, the latest science shows even if you backtrack this graph all the way through the Quaternary, 3 million years, we never passed 2 degrees. Can you imagine? Never passed 2 degrees Celsius. That is the corridor of life. Today, we are over here, and we are heading towards a point that would take us to 2.7 degrees Celsius by the end of the century. That is winding back the climate clock 3 million years. But to make the point even more powerful in the planetary boundary science term, look at this. We leave the last ice age 20,000 years ago, and we enter this remarkably stable Holocene phase. We're barely in it, and we transition from hunters and gatherers, a few million people. We're having a rough time on Earth. Why is that? Because environmental variability is so tremendous. We come into the most recent interglacial, the Holocene, which is this Garden of Eden. It's this extraordinarily stable climate, plus minus 14 degrees Celsius, plus minus 1 degree, and we barely enter it, and we go through the most important revolution of all revolutions that we know about, the Neolithic. We domesticate animals and plants. We go from being hunters and gatherers to becoming sedentary farmers. That's the takeoff point for everything we talk about in the modern world we live today. And we know today that we domesticated animals and plants roughly simultaneously across all continents at the same time. So that is proof point that it was the stability and beauty of nature. It was the stability of the rainy seasons. It was this fantastic spring started every year sometime in May. You could plant your seeds and harvest in September. Wasn't that beautiful to de-risk investments? And that's the takeoff point. And now we are already outside of the Holocene. We're in the Anthropocene, and we're putting this whole stability at risk. Do we really need to hesitate? I mean, honestly? So this is where we are scientifically. We have right at the Anthropocene, we're putting all these pressures, it's starting to hurt, tipping points are real, and we're deviating away to the Holocene. That is why the planetary boundary science was put on the table. What evidence do we use to define the safe boundaries? Well, we use a lot of different sources of evidence, but probably the most important one is the tipping point science. It's advanced roughly parallel with the planetary boundary science. The first paper was published in 2008. The Tim Lenton et al., also on the jury, by the way, together with John Schellenhuber, also on the jury. Many of you are tipping point scientists in this room. And here is the latest synthesis. This was published in 2022 in a David McKay et al. Paper. This is the first time we're able to map all the climate tipping elements on planet Earth. As you see from this map, they are everywhere. They are big biomes, there are ice sheets, there are ocean conveyor systems, there's tropical coral reef systems. The breakthrough in this work is the color scheme. For the first time, we were able to assess at what temperature levels are these systems likely to cross their thresholds. And the drama here is, in this conclusion, is that 5 of these systems, which you see blinking up now, are likely to cross their tipping points already at 1.5 degrees Celsius of global mean surface temperature rise. Greenland ice sheet, West Antarctic ice sheet, losing all tropical coral reef systems, livelihoods of over 300 million people, abrupt thawing of permafrost, and destabilizing of the Labrador Sea convection, the sea current southwest of Greenland. Now, just those 2 ice sheets hold 10-meter sea level rise. Of course, it wouldn't be a tsunami flood the day after crossing the tipping point. It may take 1,000 years for these to melt, but the rate would change and it would be unstoppable. What right do we have to hand over to future generations a less livable world that would irreversibly slide in this direction? We put the boundary to stay away from these tipping points. That's how the science advances. This means that 1.5 is not a target, it's not a goal, it's not something you negotiate with. Science shows it's a boundary, it's a limit. You want to stay away from it, you want to aim everything we can to hold off from it. Can we do that? Well, unfortunately, the scientific conclusion today is we cannot hold ourselves away from breaching 1.5. That is a dire but an honest and important information that today overshoot is, I would argue, inevitable. How does that look like? Well, to begin with, we know we need to decarbonize the global economy to have any chance of coming close to 1.5. So that's the blue journey here you have. That's quite interesting. The planetary boundary science gives us a number, the boundary, 1.5. That translates to a budget. The budget is finite. It gives us 200 billion tons of carbon dioxide remaining for a safe landing. Do you want to just burn that over the next 5 years? We emit 40 per year. You would consume it in 5 years? Of course not. You want to have an orderly phase out. So that's what science gives humanity, an orderly pathway. That's what we define as the carbon law, cutting emissions by half every decade. That's what the European Union has. John Bell is here, leading the way on the European Green Deal. That is when science really, really informs policy. A number, a budget, accounting, a pathway, a safe landing. That is the path we have to follow. But even if we follow that pathway, the latest IPCC assessment shows that overshoot is inevitable. What you see here are the 1.5 degrees Celsius aligned, so-called C2 scenarios in the IPCC that are, we're talking really SSP1, RCP 1.9 for you, those of you who are in that jargon. So we're talking about decarbonizing the global economy at record speed, but still, we will very likely crash through the 1.5 degrees Celsius boundary somewhere between 2030 and 2035. That's the best message we have to humanity. Then we have, at best, an overshoot period of some 30, 40 years between 0.1 to 0.3 degrees Celsius before we may, as you see, come back to 1.5 by the end of this century. That's like the best path we today can offer. What does this mean? Well, it means two things. It means many things, but two key messages. Number one, buckle up, because it will be a jumpy ride. Because we can say with 100% certainty that this means more extreme events, more droughts, more floods, more disease, more fires, more reinforced storms. That is a certainty. Number two, why would we come back? Why would we safely land back? Well, I can tell you there's only one answer: planetary boundaries. It requires a resilient, healthy Earth system to continue buffering and not cross tipping points. That is why we need the planetary boundary framework today. We cannot continue transgressing the climate boundary, putting the planet under a tremendous, potentially unmanageable energy imbalance, while at the same time pulling the rug out of the buffering capacity of the living biosphere, biodiversity, land, fresh water, the nutrient cycles of nitrogen and phosphorus, the ocean, air quality, because these are undermining the strength of the Earth system to be able to absorb, which the planet is doing today, 50% of carbon dioxide on land and in ocean. Why is this happening on land? It's intact nature doing it. So when you see that the planetary boundaries of biosphere integrity, land, fresh water, nitrogen, phosphorus are outside of the safe space, that is a planet that we are weakening at a point when we need a strong planet to deal with the climate crisis. So even if you care only about solving the climate crisis, I can tell you there is no Paris Agreement without planetary boundaries. Even if we phase out coal, oil, and gas, we will still fail unless we adopt a planetary boundary approach. And I'm not making marketing for this framework. You can take any framework. The key is we have to have a whole Earth system approach to have a safe future for humanity on planet Earth. Now the question is this still possible? Well, it's not only about safety, it's also about justice. Together with many social scientists, many of you in the room, we have advanced a whole new concept of redefining the global commons. The global commons, as you know, have been for 50 years understood as being the big systems outside of national jurisdictions, owned by nobody, thereby owned by all of us. Antarctica, the high seas, the atmosphere, outer space. Scientifically, we now show we have to redefine this. The global commons are actually all the biophysical systems that we collectively depend on for our livelihood on planet Earth, irrespective of whether inside or outside of national jurisdictions. This means that the Greenland ice sheet is a global commons. The Amazon rainforest, the life in Villars will change if the Amazon rainforest crosses a tipping point because of the massive carbon release that would be caused in that trajectory. The planetary commons, therefore, defines all the tipping elements as planetary commons, which would be a new governance regime for a planetary boundary future for humanity. I just share this to show that the Frontiers Planet Prize is not only about the natural science part. It's really about what does this imply for our relationship with planet Earth in terms of political science, in terms of behavioral science, in terms of equity, in terms of our ability for institutional development. And here you have the list of tipping elements and therefore the new global commons. I won't go through that list, but just show that this becomes a much more complex list. Finally, just to say that we've taken the planetary boundary science into the Earth Commission, the first attempt of having a global scientific assessment mechanism for safety and justice on planet Earth. Wendy Broadgate is here. Future Earth is hosting this for the global scientific community. We're doing this in a really synthetic way, defining in the outer circle here, confirming the planetary boundaries. But what is so important to break through in this work are the blue lines here that showed, just look at the climate wedge. The safe boundary is defined, as I've already shared with you, to 1.5 degrees Celsius. Beyond that point, we risk causing irreversible changes and crossing tipping points. That's for safety. But the big question posed by the social sciences is, at what point do we actually exceed acceptable, significant harm to people? When do we hurt people beyond what is acceptable? When do we have millions of people, communities, countries, livelihoods undermined? And the social sciences puts that number in the blue line, which is 1 degree Celsius, which means if we take justice, really seriously, we are already beyond the just level for the Earth system boundaries, but still within the safe boundaries. And the same applies for air pollution and for nitrogen loading, but the others actually safety and justice align. That's quite interesting. It's just to say that we've come quite a long way in this interdisciplinary effort. So to close this, we need transformative change. There's no longer a future for us only through linear incremental change. Last year, we produced a global tipping point report, including both positive and negative tipping point analysis. So it's quite good for you to be aware that the science also for the Frontiers Planet Prize is about scalable solutions, to find solutions that can accelerate. I often say in my lectures today that the only currency that counts today is scale and speed. There's no future for incrementality anymore. Now is the time to find the scalable, innovative solutions. We're also taking this science to a point where we are doing a health check each year, scaling up our ability to work with satellite observation providers. We're going to do a planetary health check each year, the first one released actually at the New York Climate Week this year, which is an effort of speeding up also the science. That's exactly what Camilla pointed out in terms of science. And just to close this, to say that I think we have a lot of evidence to say we're somewhere right at a tipping edge where we're doing a lot of progress, actually. We have so many of the solutions. We know that we can provide renewable energy, outcompete coal in particular, even without subsidies. We have all the solutions for a food system transition, which would take us back to essentially 6 of the 9 planetary boundaries. We know how to do circular business models. It's no longer fantasy to succeed in a safe landing, which is both safe and just. But we're still not making progress, at least not at the global level, which is what we need. So we're right at this transition phase, and now is the time, how can we speed up the pathway towards a safe landing? And I'm convinced, just as Henry and Camilla have been articulating, that science can guide this, help us at least, by defining the North Star or the Southern Cross for our transformation, and help in that accounting journey, which can also then speed up innovations and scale them in particular, and hold the world accountable. With that, thank you very much.